Yo guys, welcome to my walkthrough for the Maths A paper 3H. And this paper is from the May 2016, set in the morning, okay? So this is going to be approximately a 2-hour video, and I'm going to go through every single question, hopefully in the most efficient way. Okay, so what do we have here? So this is the Edexcel IGCSE, and I'm going to go through everything. So on the very first page, what do we have? We have the International GCSE formula sheet. So for those who don't know, you're given literally a hell lot of formulas. You've got the Pythagoras theorem, the volume of a cone, volume of a sphere, the curved surface area of a cone, and the surface area of a sphere. Then you've got Pythagoras' theorem, trigonometry over here. You got for any given triangle, the sine, cosine rules, as well as the area of a triangle. Very useful indeed. We also have the volume for prism, and yeah, you're given quite a bit. Most importantly, you got your quadratic formula, which I think we should know by heart at this stage. And yeah, so hope you guys enjoy this, and let's go in. So answer all 22 questions. All right. Number 1. Here are the ingredients needed to make 12 juicy muffins. So this is what we're given for 12 muffins. We're given flour, sugar in grams, the quantity of volume of milk, 100 grams of butter, and 2 lovely eggs. So Sarah wants to make 60 muffins. Work out how much sugar she uses. So each of this is the quantity needed to make 12 muffins. So our question is, how many times more does she need to make 60? So the smartest thing to do is to consider this as a ratio. So let's say we want 60. We want to see how many times does 60 go into 12. This will tell you how many times she needs for each of these ingredients. And doing this in your calculator, 60 divided by 12 will give you 5. So this means she needs 5 times as many of each certain ingredient. So because she wants sugar, we can say she needs 5 times 150 grams of sugar to make exactly 60 muffins. And of course she needs 5 times everything else. You can't just increase sugar and nothing else. But specifically for sugar, you enter this in the calculator, 5 times 150, and you guys should get 750 grams. All right, easy. Now how about part B? So now James makes some muffins. He uses 625 milliliters of milk. How many muffins did he make? Okay, so he used 250 milliliters of milk, but in this case he used 625. So what we should do is again divide them to see how many times the number of muffins he requires. So we can do 625 milliliters of milk and divide it by 250 to see the ratio. So dividing it in the calculator, you should get exactly 2.5 times. So he needs 2.5 times the quantity required. So because it's 12 per 250 milliliters of milk, he needs to do 12 times 2.5 to get the total number of muffins. So we can say 12 times 2.5. This should give us, guys, about, in my head, 30 muffins. And again, just like the previous question, you need to obviously multiply everything by 2.5, really, if you want to make 30 muffins. But for the purpose of this question, you just want to see how many muffins did he make. And voila, guys, the answer is 30. Sweet. Now let's move on to number 2. Alright, so we're given two values for A and C. One is -5, one is -2. And we're told to work out the value of 2a squared plus 6c. So yeah, all you literally have to do is plug these values in. So plugging in -5, so remember to do it like this. It's useful to put around the bracket, yeah? So replace the letter of a bracket in the number instead. So A would be -5 plus 6, and then open the bracket and put -2. So this is how you expect it to write this stage. Now evaluating this, -5 squared is 25, times that by 2 will give you 50. 6 times -2 will be -12, and plus -12 is -12, and this is obviously going to be 38. All right, easy. Now next part, there are 4 pens in a small box of pens. There are 10 pens in a large box of pens. All right, cool, good info. Amy buys X small boxes of pens and Y large boxes of pens. All right, so from here, she buys X lots of these pens and Y lots of these pens. She buys a total of T pens. So write a formula of this. So if you're going to think about it, because she bought X lots of 4, so that means she bought a total of 4X. And because she bought 5 Y lots of 10 pens, she bought 10 Y. And obviously this must equal the total number of pens, which is T. And literally, guys, that's it. That's number 3 done. Okay, moving on to question 3 now. So the table shows information about the number of visits each of 40 adults made to the gym last week. Okay, so here we have the frequency, which means literally the number of adults in this case. So summing up all these figures should give us a total of 40 people. And for basically what this is telling us, the number of visits to the gym. So we can say that the number of people who went to the gym, say 3 times, 5 people did that. Or the number of people that went to the gym 7 times, only 1 guy did it. So this is the only dedicated person. And of course, the maximum can be 7 because there are only 7 days in a week. Yep, makes sense. So here, work out the mean of the number of visits to the gym. All right, to calculate the mean, there's 2 things we need. One, the mean is literally the total frequency times the number of visits over the total number of people. So the first thing you need to redo is make an extra table and call it, let's say, fx. Okay, that's what you do in every mean question. And all we simply do is just multiply the rows. So 0 times 4 will give us 0. 1 times 3 will give us 3. 2 times 12 is 24, and so on. Multiply every single row. Let's see, 32, 25, 12, and 7. Okay, now in your calculator, I want you guys to add up every single term here. And when you do that, you should get, let's see, because I'm also adding them up as well. You should get, I believe, 118. And therefore, we can say that the mean number of visits to the gym would just be the total of fx over the total number of adults. So 118 divided by 40. And this should give us 2.95. So that's basically saying that on average, on average of all the 40 peoples, about you're expected to see at least 3 visits to the gym, almost 3 visits, in total 40. So that's not so bad. That's probably like us, isn't it? All right, now let's look at set theory. So we're given ABC. ABC has these elements in the set, or members as you can say. B has 1, 3 onwards, and C has 3, 6. So we can say that A are pretty much even numbers here. We have even numbers here. B are odd numbers. And C seems to be multiples of 3. So I'm just pretty much highlighting. I'm not necessarily staying anything here. So list the members of the set AVC. So what this really means is, okay, so for some strange reason, they use this notation here. What they really mean here is the intersection. So A intersecting with C, and this is A union of C. Yeah, don't ask why they wrote it like that. So A intersecting with C. How many times is A intersect with C here? Well, we can see that 6 over here and 6 over here seem to be a matching pair. We also got 12 and 12, which is a matching pair. So the only members we have are 6 and 12. Now for the union, well, the union of A and C are actually every single element in A and every single element in C. So that would mean, so let's have a look. Every single element in A would be 2, 4, 6, every even number, and every element in C is this. So let's write them out in order. So we got 2, 3, 4, 6. What else do we have? We have every single guy. So we got 8, 9. We have 10. We also have a 12, and we have 14. So this is everybody, isn't it? Now for here, explain why when A intersects B, we get something known as an empty set. In other words, we get nothing. Well, the reason why we get nothing is because even numbers and odd numbers have nothing in common. They all have opposite figures. So you'll find no intersection here. So we can say simply A consists, so keep it simple, of even numbers and B consists of odd numbers. So yeah, I mean, I wrote it in 2 different ways, but yeah, that's really it. Anyway, I hope that's done. So let's move on to question 5. Okay guys, number 5. So on the grid, draw the graph of y equals 3x minus 5 for the following values of x, which is from minus 2 to 3. Okay, easy. So all we have to simply do is just literally plug in values from this range into this formula and then put an x. So the smartest thing to do, what I would personally do, is literally just put in the first value and the final value and then draw a straight line. So what happens here? So if you plug in x equals minus 2, what do we get? We should get y equals 3 times minus 2 minus 5. And then what does it give us? So 3 times minus 2 is minus 6. Minus 5 will give us minus 11. And if you plug in x equals 3, the final value, what do you get? You get y equals 3 times bracket 3 minus 5 equals, and this value was this. What do we get here? So 3 times 3 is 9. 9 minus 5 is 4. And that's it. Now all we do is plug in the corners. Minus 2 and minus 11. Oops. Minus 11. And here we plug in 3 and 4. Alright, let's find it here. So minus 2, minus 11. Oh, so this one's quite deep. So minus 2 is here. Drop down to minus 11. And the next one we said was 3, 4. Okay, this is going to be a bit tricky because I don't have a big enough screen. Let me see if I can zoom out actually. Oh, perfect. Wait, a bit more. Yeah. Oh, come on. Oh, crap. Okay, so hold on, mind my language. So 3 to 4. Okay, I'm going to do this. Okay, don't waste too much time. Alright, so it's just over here. So let me draw a straight line for you guys, yeah? So we can be from here all the way to here. So it should cross something like this. Give or take, yeah? And that's it. So this would be your straight line, cutting from this point to that point. Yeah? So easy, isn't it? Now, let's move on. So yeah, I'm doing this on Word actually. That's why it looks like this. Okay, go back to what I was. So 100% view. Cool. Now, show that the sum of 3 over 10 plus 2 over 15 equals 13 over 30. Cool, so they kind of already did the work for us. So the bottom line, let's pretend we didn't get an answer. So to work this out, what this means is that we need to, when you add the fractions, you need to have a common denominator. So the question is, when does 10 and 15 line up? What are the common multiples? Well, we know if we did the 10 times table, we're going to have 10, 20, 30, and so on. For the 15, it'll be 15, 30, and that's it. We got it, 50, 30. So we can say that their common multiple is when they're both at 30. That's all we care about. To get to 30 for 15, we have to obviously multiply 15 by these guys by 2. And to get to 30, we need to multiply 10 by 3. Oh, I don't know why my machine is doing this, why it's misbehaving. Anyway, I'll sort out later. Anyway, for this case, let's work this out. So multiplying the left side fraction by 3, everything up and down, we're going to get 9 over 30, so it balances, plus multiplying this one by 2, we're going to get 4 over 30. And that's it. Adding 4 and 9, you can clearly see we get 13 over 30. Now, moving on to this one. God, I cannot read that number, really? So the one issue I had with this PDF is that I had to convert it to a Word document for the purpose of getting it right. But let me just pause a second. Okay, so at this stage, now we're moving to part B, 6b. So we're going to show that 2 5 over 8 divided by 1 over 6 equals 2 quarters, 2 and 1 quarters. So same thing applies. So here we're going to get the common denominator, and also because we're doing mixed fractions, we need to convert them back to their original improper fractions. So it's easy to do. So let's just focus on the left side, yeah? What do we have? So 2 5/8. What this means that we have two whole numbers and a fraction 5/8. To make it a whole, my technique is to multiply 2 by 8. So we're going to have 16 over 8. Added to the 5 will give us 21 over 8. And the next part. God, what's this ridiculous thing happening here? It's dividing. We're going to fix that later. Next one would be 1 and 1/6. So again, make a fraction out of the whole number 1, which is 1 times 6 is 6 over 6. 6 over 6 plus 1 will give you 7 over 6. And that's it. Now, because we're dividing a fraction, all we simply do is flip the second and stick in a time state, stick in a time sign. So we've got 21 over 8. Oh, Jesus. Sorry for my language. 21 over 8 times 6 over 7. And now, if you can, so one cool technique is to try and simplify this before you solve it. So try and cross simplify. So we can see that 7 goes into 21 3 times, so divide them both by 7, so you should get 3 here and get 1. 6 and 8 are both in the 2 times table, so divided by 2 you get 3 and 4, and that's it. Now you got 3 times 3 is 9, 4 times 1 is 4, and that's it, guys. You get 9 over 4. And to retain it back to 2 1/4, we can say that we can also solve how many times is 4 going to 9? Well, it goes exactly 2 times, will remain, and has a single remainder, so 1 over 4. That's it. All done, guys. Now let's move on to the next part. Alright, so let's factorize number 7. So how to factorize 3y squared plus 2y? Well, let's see. We can pull out y firstly. Let's find out what's in common. Y is in common, so we've got y bracket. We're left with a single y here, and no y is here. Now, next part would be, oh no, that's it. You can't do anything else. You're done. There is no number terms in common, just y. So how about this one? Expand and simplify x minus 9 times x plus 2. Again, easy. So we'll go use a FOIL method. So what I will do, I will times x with x with 2, and then the next one would be the inside part. So minus 9 and x, and then minus 9 and 2. So x times x is, let's see, x squared. X times 2 is 2x. Minus 9 times x is minus 9x. Minus 9 times 2 is minus 18. And now we just go do simplify these terms because they have like terms. Now 2x take away 9x. What does that give us? That should give us negative 7x. So the final solution will be x squared minus 7x minus 18. Okay, coolio. Now solve this one. All right. So when you get inequalities, treat them like pretty much a normal equation. So pretend this is an equal sign and just solve okay. So in this case, what do we have? So we've got 6k plus 5 less than 20. So what we could do is eliminate 5. So subtracting 5 will give us 6k less than 6k less than 20. Take away 5 is 15. And you just then split up the 6 and the k, you just divide by 6. So it'd be k over 15 divided by 6. And yeah, we could actually simplify this part. So 15 over 6, both go to 3, divided by 3, you should get 5 over 2. So k is less than 5 over 2. That's it. Okay, so interesting question. N is an integer in this equation. So this is the same equation as that. Write down the largest possible value n. So n was an integer, and we know that, and say in this case, we know that n is less than 5 over 2. And just to make a clear point, 5 over 2 is the same as 2.5. Yeah, you can check that on your calculator. So we're going to pick that the biggest value n, where is less than 2.5, is integer. Well, we know the integer is a whole number, so the biggest whole number you can have, less than 2.5, is obviously a 2. So n equals 2. Well, you get 3 marks for all of this. Easy. Now finally, simplify this equation here. Okay guys, let's simplify part D now. So we have simplified fully 28x to the power 5 times y to the power 3 all over 4x y squared. Now this is easy. We just look at the numbers and simplify that, then the x's, then the y. So first things first, what is 28 over 4? We know 4 goes to 28 exactly 7 times. We know that x to the power 5 over x, so this is a single x. When we divide like terms, we just subtract the powers. So 5 take away 1 would be x4. y3 take away, divide over y2 would just be y1 or just y. And that's it, 7x4, x to the power 4 and y. Moving on. Now in this question, number 8. So here we're given a right angle triangle with an angle 53 over here and 13.4 centimeters from length BC. Work out the length of AB. So to work out length AB, let's give it a name, call it x. Give your answer correct to one decimal place. Alright, so they don't tell you nothing here. We just need to think what method to use. So we got two choices. So actually we got one choice. Because it's right angle triangle, you're either going to use Pythagoras theorem or trigonometry. We're dealing with angles, so we must use trigonometry. Easy way to do this, let's start labeling sides. Every time we have an angle opposite, if we're dealing with a certain angle, the length here is always known as the opposite in terms of angle. So this x here is known as opposite. And the longest side is known as the hypotenuse. This side is known as the adjacent. The AC is adjacent, but we're not interested in that. So we need to think in terms of trigonometry. What has op and hype? What has O and H? So we record the term so, ka, toa. Okay, so is sine equals opposite over hypotenuse. So opposite over hypotenuse. And yes, that's it. We're not going to use ka because we're not using adjacent. We're not going to use toa because, again, we're not using adjacent. So is the only option. So this means we're going to use sine. So it'll be written as this. So soa, it means sine and the angle 53 equals opposite over adjacent. Opposite being x over adjacent 13.4. Now solving this, you just make x a subject. And to make it, well, we know that we have x divided by 13.4. We need to times 13.4 both sides. So times 13.4, we're going to get 13.4 times by sine 53 equals to x. And that's it. Now all we do is plug this in the calculator. So for x, we're going to have 13.4 in the calculator times sine 53. And that should give us 10.7 centimeters to 1 dp. Cool. Moving on. Oh, that's it. There's no other questions. Cool. All right. This is really easy, guys. So number 9. So Bhavin, Max, and Imran share 6,000 rupees in the ratio 237. Man. Nice. That's pretty cool. And Imran then gives 3/5 of his share of the money to Bhavin. What percentage of the 6,000 rupees does Bhavin now have? All right. So first thing we want to do, we're given ratios. Okay, so let's find out how many parts there actually are. So with any ratio question, we know that we must add up all the parts. So adding 3 plus 7, 2 plus 3 plus 7 will give us a total of 12 parts. This means that 6,000 rupees is equivalent to 12 parts. So to find how many rupees are in a single part, we can obviously divide everything by 12. So we can say that by dividing 12, 6,000 in your calculator divided by 12 will give us exactly 5,000 rupees. So 5,000 rupees equals a single part. Okay, now if we want to find 237, we're going to multiply the number of rupees by 2 parts or 3 or 7. So what else do we know? We know that Imran gives 3/5 of his share of the money to Bhavin. So Bhavin represents 2 parts. What percentage of rupees does Bhavin now have? Well, firstly, how much money does Bhavin actually have right now? So Bhavin actually has 2 parts. So doubling this one, we're going to have 1,000 rupees. So Bhavin has 1,000 rupees. He gives, is right, equals 2 parts. He gives 3/5 of this money. So, okay, that's how much Bhavin has, sorry. Imran gives 3/5, so we need to work out how much Imran has. Okay, so yeah, Bhavin has this much. So Imran, he has 3 times 500 rupees, so he has exactly 1,500 rupees right now at this moment in time. Equals 3 parts. He gives 3/5 of his money right now to Bhavin, so he's going to give 3/5 of 1,500. So what is 3/5 of 1,500 right now? So you can literally times that by the way to do 3/5, you can just do 3 times 1,500 divided by 5, or divided by 5 times by 3. So either way works. So quickly doing in your calculator, you should get exactly 900 rupees. Okay, so 3 times 1,500 over 5 will give you 900 rupees. And we know that Imran gives 900 rupees to Bhavin, so therefore Bhavin now has exactly 1,000 plus 900, 1,900 rupees. As a percentage, well, divided by 600, because it goes off 600, off 6,000. Divided by 6,000, and therefore 1,900 over 6,000 should be, I'm actually calculating now, about, to the nearest whole number, 32%. And that's it, 32%. I mean, so that's pretty much the steps. So always find the total ratio, divide it by the number of parts, and then calculate any other intermediate steps, like 3/5 of his current money, and gives it to Bavin, so on. All right, easy stuff. Let's move on. So let's just double check. 3/5 of his share. Yep, easy. All right, next part. So the diagram shows a circle inside a rectangle. All right, so we've got a circle here which is 2.5 centimeters, and we've got a rectangle which is 13.8 by 7.6. Work out the area of the shaded region. All right, so this one's not too bad. So we look at so we got to think of two things. Firstly, we need to know the area of a rectangle and an area circle, and we can see that the area circle has been removed from the rectangle. So if we're going to write this out, in words, we can say that the area of a rectangle, the area of the whole shaded region is the rectangle minus the area of a circle. If we can do this, we should get an answer, correct? So what is area of a rectangle? Well, area of a rectangle is just base times height, so 13.8 times 7.6. And then the area of a circle is pi r squared. So this is something we should try to memorize, pi r squared, yeah? So r being the radius of 2.5. So we can say the area of a circle will be pi times the radius 2.5 squared. Now all you do is work out both of these, subtract from each other, and that should give you the total area. So let's just quickly take our time and do it. 13.8 times 7.6, and then press minus pi times 2.5 squared, and to three significant figures you should therefore get, so where's the answers placed, you should get a solution of 85.2. Yep, 85.2 centimeters squared. Is that correct? Yes. All right, cool. Let's move on, guys. Ooh, cumulative frequency. Yeah, boy. All right, so let's have a go at this stuff. So the cumulative frequency shows information by the weights of 80 adults. So we've got 40 less than WTM, all right, not TM. So this is probably another less than sign. Less than W, less than 50. 50 less than W, less than 60. So we got weights between 40 and 50, 50 and 60, and so on. And these are the number of adults. All cumulative means is that we're pretty much adding as we go. So we take into account everybody from 40 to 50 and everybody from 40 to 60. So notice that the width is gone wider because we're accumulating these two groups. We're accumulating 4 and 7. So 4 add 7 should give us 11 here. The next one would be 40 to 70, so we're adding all three groups. So the quickest way is to just add as you go. So the way we're going to do this, we're going to add as we go. So we've got 11 plus 21 will give us 32. 32 add another 21 will give us 53. Add 18, 71. Add another 7, so check we get 18 and add another 7, we're going to get 78. And lastly, add 2, we're going to get 80. Is it correct? Yes, because there was 80 adults, and you must get a total of 80. Cool. Okay, so the next bit, part B. Okay, so here we have a grid, and we need to draw what we just found into our graph. And then we need to estimate for the number of adults or weights more than 85. Okay, let's get the part C in a minute, yeah? So, how to plot this? Well, looking at our table, we need to think about how to really interpret this. So, we could say, for example, that for adults up to, for adults weighing up to 50 kg, so let's have a look. We can guarantee that there's going to be 4 people. So we can say the first point, oops, that's my rubber. Eraser. Yeah, so we can say there's going to be a total of 4 people weighing up to 50 kg. Okay, and for next one, for up to 11 adults, we can guarantee that there's going to be up to 60 kg in weight. And we can do this all the way, literally, up until every single person. So we can say for every single adult, we're guaranteed to have weights up to 110 kg, assuming the lower bounds are all 40, yeah? And that's it. So if we're gonna have, so what this tells us is that we're gonna have an increasing curve because everything seems to be going up. But we need an initial point. We need something when there's nobody. So we can say, because we're working up to 40 kg, we can say when there's nobody, most likely nobody is at 40 kg for our sample size. So this is a fair estimate. And that's it. Now we just plot these guys into the curve. So we've got 0, 4, 11. We're going up in 10, so that's easy. So we can do 0, 40, 11, 50, and so on. So let's just look at these figures here. So we've got 4, 11, 32. So at 40, we're going to have 4, 40, 0. So 4 would be here. Up to 50 kg, we're going to have 11, so 11 should be between here. So remember, we're going up in 2s here, yeah? These blocks are up in, these little squares go up in 2. Oh, for 60, we're going to have, hold up. Yeah, okay, I'm fine. Just thought I made a mistake here. So 11 would be 60. Okay, I think I did do a mistake. Yep, it should be the other way around. Hold up, guys. Let me just erase this. So yeah, trust me, even we can make mistakes. So yeah, that makes sense. At 40, obviously you have to be at 0. So 50, we're going to be at 4 kg. At 60, you're going to be up to 11. What's next? God, this will take forever. So 32, 53. Let's have a look. So 32 would be here. So try and copy this as we go. Next one was it 53? I said 53, then 71. So those up to 80 kg could be 53. 53 must be here. 71 for 90 kg. So 90 kg. So that's 71, isn't it? So 70. Oh, my eyes are deceiving me. Okay, let's just say it's here. 71. Wait, 100 would be 78, and the last one would be 80. Okay, so you can see it kind of cuts off around there. So 78, and then finally 100. And that's it. Now we just draw. Now we draw a curve, a nice smooth curve. It's ain't gonna be smooth. Oh, not bad. Come on, don't mess up. Don't mess up. Yeah. Okay. Not bad. So yeah, that's the curve. So obviously you guys will make it look a lot nicer though. Yeah, and we're done. Now, all right, so use your graph to find an estimate for the number of adults who weigh more than 85. So pull out your rulers now. I'm going to get a straight line here. So we need to find weight more than 85. So where's 85 margin? It's bang in the center here. Draw a straight line up. And we can see it cuts off around here, around the 60th mark. So we can say the number of adults more than 60. So we're going to look at this interval. More than 60. So we have more than 60. We have a total number of 20 adults that are more than 60. So the answer would be 20. And then use your graph to find an estimate for the interquartile range. So the interquartile range is simply, we're going to divide the cumulative frequency into quartiles. So we can say the interquartile range is simply the third quartile minus the first quartile, the value of that. So we look at the first quartile. So the first quartile of 80 would be 20. So a quarter of 80 is 20, and 3/4 of 80 is 60. So this is the range. Now we just draw a straight line. Yes, so let me try and get this straight. So we just draw a straight line across. Let me get another shape. Okay, so start from here, straight line across, and you can see it cuts off around here. And then do the same thing again. Oops. So again, another straight line, start from 60 and all the way. Conveniently, we know what 60 was. 60 was this value here was 85 kg, and this value here at 20 should be about 67, 8, 9. So 67. Let's say 67. Yeah. Let's say 67. Here was 85. So the interquartile range is the difference basically. So 85 kg minus 67, and that's on the calculator 18 kg. Oh god, not this again. 18 kg. Cool. Let's move on. Oh man, you know, I'll be honest, I'm so glad we've done the cubic frequency. It's the one question I don't even like to do, I'll be honest. Anyway, let's keep going, guys. So now let's solve the simultaneous equation. Thank God, algebra. I love you, algebra. So look at this pair. So the main idea to solve this easily, because they're both linear equations, that is, there's no x squares or y squares or nothing crazy. They're just simple x's and y's. All we have to do is make the coefficient, the number in front of the x or y, is the same. Just like when you add fractions. So looking at the first equation, we've got 4 and 3. So all you really should consider is when are they both, what is the lowest common multiple. So again, quickest way to do it is just multiply this whole equation by 3 to get this to 12, and multiply this by 4 to get this to 12. So the LCM basically of 3 and 4 is actually 12, because our 3 times tables go to 12, 4 times table go to 12. So to do this, multiply all of this to get to 12 by 3, multiply all of the second equation by 4 to get 12x. So let's have a go. So the first equation, if you multiply by 3, you're going to get 12x plus 15y equals, so 3 times 39 is 39. What do you mean? 13 times 3 is 39. Multiplying the second equation here by 4, you should get, obviously 12x, that's our target, minus 8y equals, so 27 times 4, I think 108. Yep, double check that. 27 times 4, 108. Yes, good. My maths ain't failing me yet. Now we just want to subtract them, don't we? So subtracting all of these guys, 12x take away 12x is nothing. 15y take away minus 8y, so minus minus makes a plus. 15y plus 8y will give us 23y. So I don't need to put this here, the 0. And lastly, 39 take away 108 gives us minus 69 equals minus 69. And voila, all we do now is find the value of y, so dividing both sides by 23 should give us a clean negative 3. That's it, guys. Now all you want to do is plug in this value to find the x value, because remember, when you find 1, don't think it's over, because you lose some marks. You've got to find x and y. They even tell us here, which is great. So I'll just put minus 3 down here because we did it. Now to find x, plug in minus 3 into any equation. Pick the easy equation. I mean, I'll pick the first because it looks more straightforward. So plug in minus 3 into the first equation here. We're going to get 4x plus 5 times negative 3 must equal 13. So this 5 times negative 3 will be minus 15. So we're going to have 4x minus 15 equals 13. To get rid of the negative 15, we need the plus 15. So we're going to have 4x equals, so plus and 15 will give us 28 on the right side. And then dividing by 4 to clear the 4 will give us x equals, so 28 over 4 will give us 7. So finally x equals 7, guys. See, this is why I like simultaneous equations. Algebra is just so quick and easy. Now let's move on to number 13. Alright, let's have a go. So I just had a little break in my head. So number 13. The straight line L passes through the points minus 2 and 3 and 0.69. So 2 coordinates, yeah? Find an equation of the line that is parallel to this line. So we have a line to this line and passes through this point. Give your answer in this form. So don't worry. So let's ignore the first sentence for now. So first thing first, we need to make an equation that passes through this point. So how do we make a standard equation? Well, the standard equation is always y equals mx plus c, correct? Now we know that these 2 points fit in here, so we can say at minus 2, 3, plug in this into this equation, we're going to get, replacing x with minus 2y of 3, we're going to get 3 equals m times minus 2, which is minus 2m plus c. Now plugging in the second point at 6, 9, y is 9 and x is 3, we're going to get 9 equals, so 6 times m would be 6m plus c. And that's it. Now we just solve these simultaneously. So what we could do, subtracting both equations. So let's do let's do the second equation minus the first equation. So 9 take away 3 will give us a 6. 6m minus 2m will give us a positive. So 6 plus 2m will give us a 8m. And c, take away c will give us 0. And that's it. So now solving this equation, finding the value m, dividing by 8. So 6 divided by 8 will give us 3/4. So we can say that the gradient is 3/4. So we found the m part. So remember, for y equals mx plus, we need to find the gradient y and c in the y-intercept, which is the c. So now all we do is literally plug this into any of these two equations to find the value of c. So let's plug into let's say the first equation. So we're going to have 3 equals minus 2 times 3/4 plus c. So rearranging this, so making c the subject. If you move all of this to the left hand side, so add 2 times 3/4, you can have 3 plus 2 times 3/4, and it will give us 9/2. And that's it. So c is 9/2. And that's it. Now therefore our final equation, or our equation for L, is going to be y equals 3/4 x plus 9/2. Alright, so that's the first statement done. Now we need to find an equation that's parallel to this equation, to this line, and pass it through this point. So once again, let's do the same thing. So for the second equation, we need to see the keyword. So the keyword is parallel. Parallel means that we're going to have the same gradient. Of course, the intercept will be different. It just means that we have two lines running in the same direction. So they must have the same gradient. In this case, well, not this direction, it's going to go upwards because it's a positive gradient. Okay, so we can say for sure that the second equation is going to look something like this. Y equals, so mx plus c, y equals 3/4 x, and we don't know what the second c is. Let's call this one a d or something, because we don't want to mix up this c with this d. Yeah, so, and we also know that this line passes through 5 minus 1. So plugging in the coordinate 5 minus 1, again the same step, so at 5 minus 1, we're going to have, so minus 1 is y, x is 5, so we're going to have minus 1 equals 3/4 times 5 plus d. Alright, so now let's try and smash this quickly. So minus 1 equals 3/4 times d, so minus 1 equals 5 times 3 is 15/4 plus d, and therefore, what's the value of d? Minus 1 minus 15/4. Hold on, I'm writing this down. So work out on your calculator, you should get minus 19/4. Whee, almost. And let's just, now we can plug this back into our original equation. So therefore, this equation becomes y equals 3/4 x minus 19/4. And I mean, you'd think we're done here, don't you? But we want to put this answer into ax plus by equals c. So we need to put everything except the intercept to the other side. So therefore, just multiplying the whole equation by 4, we're going to get 4y equals 3x minus 19. And we want ax plus by, so we need to minus 4y across and plus 19. So we can say the solution is 3x minus 4y equals 19. And that's it, guys. That's your solution to this problem. Whew, that was intense. Okay, let's take a little breather for a second here. So let's move on slowly. Okay. Alright, so number 14, let's have a go. What do we have? So we have a particle is moving along a straight line. The fixed point O lies on this line, okay? The displacement, so displacement is a kind of a vector quantity or a version of distance of the particle from O at time t seconds is s meters, where we're given this equation in terms of t. So s equals an equation in terms of t. So find an expression for the velocity v of the particle at time t seconds. Okay, so this one is a very is a question which is hidden as a question of differentiation. So this is just a straight up derivative. Now, one thing we need to know about the relationship between displacement s and velocity v. We need to know that the velocity is actually this. It's the change in the distance over the change in the time. Okay, so you notice that this is a derivative. So what I'm saying literally is to differentiate this equation to get the velocity. So to differentiate this equation, let's have a go at it. So all you have to do is subtract the power and drop in front of the t value. So 2t cubed differentiate, it will give you 6t squared. So you literally drop the 3 down, so you get 2 times 3 is 6. Subtract 1 to the power, you get 2. Now repeat the next one. Dropping the, so 12t squared, drop the power, you get 2 times 12, which is 24t, and then subtract 2 minus 1 to give you 1, so 24t. And lastly, 7t. So imagine there's a power 1 to the t. So it'll be, differentiate that, you drop the 1 to the 7, so 7 times 1 is 7, and then you got t to the power 0, which vanishes, so you have 7. And that's it, that's your velocity equation. So this will go right here. Cool. Now, find the time at which the acceleration of a particle is instantaneously at 0. Okay, let me double check that in the PDF. Yeah, so this just means, this is just the, I think that's just a little mistake. Let me correct it. Okay, so now we go find acceleration. So what this means that the acceleration occurs, so the acceleration is defined as this. It's the change in velocity over time. So what this means, oops, change in v, not t. So we got to literally differentiate the velocity this time over respect to time. So find dv over dt. So that's it. And then when it equals 0, it means the acceleration will be 0 at this point. So we got to differentiate this and set this equation to 0. So differentiating the v equation, do the same method, drop the 2 down, we're going to get 6 times 2, which is 12t, and then minus the derivative of 24t should give you 24. And if you differentiate constant, you get 0. And that's it. And because the acceleration is 0, we can say, therefore, a equals 12t minus 24, and all of this equals 0. Now, solving this equation, 12t minus 24 equals 0. Well, plusing 24 on both sides, you get 12t equals 24. Dividing by 12, you get 24 over 12, which is 2. So the final solution is 2 seconds. Wait, is it in seconds, right? Yeah, seconds. And that's it, 2 seconds. Hope this helps. Let's move on to number 15. Alright, so the diagram shows 2 mathematically similar vases, A and B. Coolio. So vase A has a surface area of 112 centimeters squared, B has a surface area of 750 centimeters squared, and a volume of 1600 centimeter cube. Work out the volume of vase A. Alright, so I think first things first, so we need to recall some formulas here. Okay, so looking back at this question one more time. What we can instantly say that because the statement says mathematically similar vases, we can say that A is directly proportional to B. Or at least because in terms of area, it's the square of B is directly proportional to the square of A. So let's put this in maths terms here. So working with surface areas, because that's the common things they have, and this is an area equation, we can say that 120 centimeters squared is directly proportional to 750, or we can say 120 equals k squared times 750. Why do we put k squared instead of just k? This is because we're working with areas. Likewise, if we did the volume of A, it would be, let's call the volume A V. Yeah? We could say the volume A VA is directly proportional. I can put like a 2 sign here for square, cube sign. Is directly proportional to the cube of the volume of B, which is 1600. And this would mean VA equals k cubed times 1600. Obviously, we need to know what k is, don't we? So, basically, what we can say here directly, so we should work out the value of k for the second equation. So let's work out this one. We can say that k squared clearly equals 120 over 750. So k equals the square root of 120 over 750. And that's it. Now to work out the volume A, you just plug in this k here. So the volume A equals k cubed, so the cube of this. So let me make it bigger. So 120 over 750 all cubed times 1600. Now, I don't know what that gives us, so I need to work out too. So yeah, so that's pretty much the main idea. So you kind of have to, when you're working with areas and volumes, you kind of need to put squares and cubes on the k. Because remember, this is all scale factor. So what's it give us? We've got 120, the cube root of 120 over 750, let me just quickly do this, times 1600. And this gives us a volume of, let me double check that, it's 120 over 750, correct? And this gives us, oh yeah, I didn't do it properly. I have to cube the result. Bear me a second, guys. Square root. Okay, yep, I got an answer. I got 102.4. So 102.4 centimeter cubed. Cool. I think that should be it. All right, yeah, so that should be correct. All right, moving on now, number 16. So we got A, B, C, D, E, F, G, H is a cuboid. Ooh. And you can see there's something missing here, isn't there? It looks like it's a broken box. I think it's a broken box. So the cuboid has a length of 17, width of 5, and height of 8. Work out the size the angle AH makes of the plane EFGH. Okay, so the angle AH, let's find AH firstly, yeah? So let me just get a straight line, draw a shape here. So we're going to connect A to H, so you need to get a ruler for this. And we need to make the angle AH makes with the bond plane, which is down here. Okay. No, but okay, so that's not really the plane. So you could say the plane would be let's make a center point here. There you go. This would be the plane. So yeah, we can pick any coordinates. So we could actually extend the line even. We could say the plane connects with H. So you need to pick another letter. Let's say F. There you go. So this is the plane, because at this point when you're running through H to F, you're on the ground. So this is the angle on the ground. Okay, so let's move on from there. So what we can say, we need to find a couple lengths. We need to find the diagonal length here and the long diagonal length here of AH. And then we can use the cosine rule, I believe, to get the final result. So let's have a go at this. So the first length we want to find is AH, okay? Let's do AH. We know AH is the long diagonal, and there's a cool formula that they use here. They use 3D Pythagoras to find the diagonal of the long length, which is like this. Suppose you got, let's call this length A, this with the width B, and the height C, and the diagonal D. We can say that D squared equals A squared plus B squared plus C squared. And this will give us a result. And because we have ABC, we can say, therefore, D squared equals 17 squared plus 5 squared plus 8 squared. Okay. Now, all you have to really do is put this in your calculator, evaluate this. So when you do 17, when you evaluate the whole chain, you should get 378, and the square root in that figure would give us exactly, on the calculator, is 3 root 42. So this is what the calculator says. You might get a similar answer, but this is a simplified version. So that's the whole diagonal of AH. Now how about the diagonal on the plane? So remember, this is just a 2D Pythagoras. So this is A squared plus B squared equals C squared. So we can say for the length HF or FH, we can let that diagonal on the floor be C. So we're going to use different letters again. So this, actually let's call this an E so it doesn't mix up. So we're going to have, we're going to have A squared plus B squared equals E squared. So E squared equals A, oh man, what's this equation? E squared equals A squared plus B squared. And we know what the value A and B is 17 and 5. So we're going to have E squared equals 17 squared plus 5 squared. And then doing this in your calculator, just like the other one, and square rooting these figures. So 17 squared plus 5 squared will give us 314. Square root in that will give us root 314. So I guess I'll keep it simple here. Now, what do we do? So now we've done this, so now we can start labeling. So we got the length of D, the length of E, and we know the length of C is 8. So now we have to use the cosine rule. Okay, so this is the tricky part. So let me just do a little sketch here, yeah? So I'm going to use some of the functions that we have here. So ink the shape. I'll draw a straight line here, and a straight line here, and we'll draw, let me make it longer. Yep, okay, now that's not what I was going for. Hold on. I'm trying to make a big triangle. There you go. Yes. All right, perfect. So that would be this angle here, D, E, and C. So we're going to have let me take off this to ink the shape. So we're gonna have D, the length of D, which is 3 root 482, the length of E, which is root 314, and this length here, the height, which is 8. And then we're gonna find the angle between it, which is, let's call it X. So here again we must use the cosine rule. Okay, let's have a go. Okay, here we are. We're going to use the cosine rule now. So let's just label each side appropriately. So with the cosine rule, this will be the general formulas. So we know that the general formula is a squared equals b squared plus c squared minus 2bc times cos a. Okay, so it's important to know that the length a is always opposite the angle a. So just because it's a single angle, we need to assume that this x at this point is angle A, and this is the opposite, length A. This means that one of these two would be B or C, and it doesn't really make a difference. So therefore, using a formula and replacing everything, we should get 8 squared, which is 64, equals B squared plus C squared, so 3 root 42 all squared plus root 314 all squared. That should give us, quickly just doing it, squared plus 14 should give us 692 minus, then you do the same thing, so minus 2bc minus 2 times 3 root 42 times root 314 multiplied by cos x. Okay, so now all we have to do is make simply cos x a subject here. So let's just do some faster rearranging. So therefore, to make cos x subject, we need to subtract 692 and divide minus 2 times this quantity. So therefore we have 64 minus 692 divided by this quantity, which is minus 2 times 3 root 42 times root 314. And all of this must equal cos x. Okay, so in your calculator, have a go at this first. Try simplifying this unless you've already done this. And if you did this, you should get the following result, which is root 314. You should get a value of 0.911, and then cos inverse that, the angle should be 24.3 degrees. Okay, not bad, not bad. So double check, correct me if I'm wrong, but I think you should get a result very close to that. Now moving on to number 17. What do we have? So the diagram shows a trapezium. Okay, so we have also so just FYI, we have the trapezium formula back in the beginning, and all measurements on the diagrams are in centimeters. Cool. The area of the trapezium is 119. So let's write that in. Show that you can form this equation with using the area formula. Okay, so first things first, what is the area for trapezium? Well, the area of trapezium is always, as a triangle, it's like base times height over 2. But in this case, it's the average of the two lengths times the height over 2. So the average of these two would be summing these two and dividing it by 2. So you can have x plus 6. So this would be a plus b term. Oops. Minus 4 over 2 times x minus 1. And then, if you remember carefully, it should be also no, that's it, sorry. So that's the formula, so just double check. So it's a, so in your formula it should say half times a plus b, which are these two lengths, a and b. So the average between these two times the height, and this should give you area. Okay, so we know the area, all of this must equal 119, and that's it. Now we just solve this algebraically. So first things first, because you can consider the half as collectively combined with everything, we can multiply everything by 2. So multiplying by 2 to cancel the half, we should get exactly, let's make a big bracket, x plus 6 plus 3x minus 4 times x minus 1, and that equals, so 2 times this will give you 238. Now let's simplify the inside bracket. So x plus 3x is 4x, and then 6 take away 4 is 2, and then we multiply that as well by x minus 1, and And again, this all equals 238. Now finally, expanding this, we should get a similar term, and then we'll probably need to half it then to get 2x squared. So let's do it quickly. So expand this completely. 4x times x using the 4 method will give us 4x squared. Yeah, so and then you do 4x times minus 1 is minus 4x. So minus 4x plus 2x is minus 2x. 2 times minus 1 is minus 2, and this equals 238. Now, putting everything onto the left-hand side, so it looks a lot like the original equation. So we should get 4x squared minus 2x minus, so subtracting 238, we can get minus 2 minus 238, which is minus 240 equals 0. And clearly, if we divide all this by 2, we should get the original equation. So dividing by 2, we should get 2x squared minus x minus 120. Cool. So that's been shown. Now, obviously, we need to solve this equation now. So find the value of x. Sure, you're working clearly. Let's just use the quadratic formula actually, because it's easiest to use. So quadratic formula tells us that we need three values of ax. We need the value of a, which is 2, b, which is -1, and c, which is minus 120. Okay, I'm going to assume that you guys are okay using the formula. So writing the general formula, it's going to be x equals minus b plus minus the square root of b squared minus 4ac all over 2 times a. So plug in our values, we got minus b, so minus 1 will be plus 1 plus minus the square root of 1 minus 1 squared is 1 minus 4 times a times 120. So 4 times a is 8, and then you're going to have 8 times 120 minus 120, which give us plus. So it's going to be, let's do it quickly, 4 times 2 times 120, which will give us 960, so plus 960. All over 2 times a, which is 4. And that's it. So now, because thankfully this is a calculator exam, so really just put the whole thing inside your calculator. You don't really need to do it in steps. So let me just type it all in. So your first, oh wow, you get a whole number. So your first solution to x is 8, and your negative solution is minus 15 over 2. And just to make it clear, because we're dealing in terms of areas and in terms of lengths, we need a positive length. The second solution would be minus 15 over 2, which is here, I'll write on the side. The second solution is minus 15 over 2. So this wouldn't work because you can't have a negative length. That's really it. Alright, moving on. Okay, so algebra, nice. Making t the subject. Okay, this is easy. So we've got m equals t plus 1 over t minus 3. So first thing we're going to do is always clear the fraction. So we've got t minus 3, let's multiply t minus 3 across. So we're going to have m times t minus 3 equals t plus 1. Now expanding the left hand side, we should get mt minus 3m equals t plus 1. Now the smart thing to do is to keep all the t's on one side and all the non-t terms on the other side. So here, let's subtract t and then let's plus 3m. Okay, so subtracting t, we're going to have mt minus t, and plusing 3m, we're going to have 3, oops, that should be a t. We're going to have 3m plus 1. Okay, let me make that t more clear. Okay, plus minus t. Okay, so now there's a trick here. The trick is to get a t out of these two, you need to factorize t out. So if we factorize t, we should be left with m minus 1, and then copying that to the right side, 3m plus 1. And lastly, we can divide by m minus 1. So therefore, t equals 3m plus 1 over m minus 1. Voila, easy. Moving on to number 19. Okay, let's begin this one. Okay, so 19. All right, so here we're given a circle geometry question. So let's try and crack it down. So we've got A, B, C, and D are points on a circle with center O. Angle DAB is 75, and we've got a point here, which we don't know. We have an angle DBC, which is 27. Okay, so this one looks a bit like a cyclic quadrilateral because you have 4 points hitting every point. We also have an angle in the center which is known to be double this angle here. So work a size of angle ODC. All right, so let's try and investigate it. So let me just zoom this up a bit. Zoom, 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 zoom. Okay, hopefully this is clear. Yep, it's in the margin. It's in the recorded area. So first thing you want to know that for any circle property, the angle at one corner is always going to be half the angle at the center of the circle. So if this is 75, here this must be 2 times 75. So it's going to be 150. Okay, let's make that not too bold. 150. Okay, we also know that the sum of each opposite angles in a cyclic quadrilateral. So this is called a cyclic. It's called cyclic because you've got exactly 4 corners around the circle here and at 4 different points. And we know that the sum of, well, we don't know if we know it, but the sum of 2 corners is 180, opposite corners, and the other 2 opposite corners are also equal 180. So let's call this cyclic. So we're just trying to figure out every single property here. Quadrilateral. God, I hope I spelled it right. Is it quadra? Always forget. So ODC. And so where is ODC anyway? ODC is ODC. Okay, so we need the collective angle here. ODC. Is that right? Yep. Okay, so we got 150 there. So we know the sum. So A plus. So basically, we can say also that A plus C equals 180. Let's just call that the vertices. So I should really call it angle DAB plus angle DCB. So that's what I mean by these 2 points. DCB equals 180. So this is 75. To make 180, we need an extra 105. So 105. Okay, almost there. Almost there. So far it's looking good. Now we also know the sum of this entire region would equal sum of this region. So this is 150, 75. So we are almost there now. Actually, no, what am I talking about? We are finished. Or almost finished. So we got 27, 105. So we can actually work out the angle of this triangle here. So we know that the sum of all angles in triangles is 180, so we got 105 plus 27 plus this missing angle. So if we work out quickly, add up 105 and 27, subtract it against 180, you should get 48 over here. Cool, almost done. And now we need to work out, so we're working out ODC. ODC, so we need the sum of these, so we also need to find the value of this angle here. Let's call this one X. Okay, so take all this knowledge in. We're almost there, guys. We're trying to do as many properties as we can before the end of this question. And now to calculate the value X, this is going to be easy. So so let's just consider DOB. We have an isosceles triangle here in our hands. So the reason why it's isosceles, so every time there's a chord involved and we got center O and it's connecting to 2 ends of the chord, for any chord it's always going to be isosceles. It's always going to be X, so it can be any position as long as you got center in a chord hitting at both ends of the chord. So we can even call this value X. So because of this, we can assume that because this whole triangle adds up to 180, subtracting 150 we're left with 30 degrees. Therefore the X values are equal, so we can divide 30 by 2 to give it equal value. So X here equals 15 degrees. Therefore, angle CDO would be 48 plus X. So lastly, angle CDO would equal 48 plus X, which is 15. And that's it. The answer is 63 degrees. Not bad. Not bad at all. So I think we're done here. So 63 degrees. Let's go back to our normal zoom. So yeah, I'll just write the answer here, 63. Now let's moving on. Yeah, that was definitely challenging, wasn't it? So 20. A metal cube has size of length 4.5 to the nearest 0.5 centimeters. So this is being rounded, yeah? The length has been rounded. Because it's 0.5 centimeters, and it's to the nearest, we should assume that it's been taken halfway up and halfway down of this value here. So half of 0.5 would be plus, it's going to by plus 0.25, or it's being rounded downwards by minus 0.25. So these are bounds, okay? We're looking at bounds. Okay, so these are in centimeters too. The cube is melted down and the metal is used to make small spheres. Oh boy. Each sphere has a radius of 3 millimeters to the correct to nearest millimeter. So again, to the nearest millimeter, we've got half the millimeter, so we're going to have, so let's just write a unit. So we've got centimeters here, and we've got centimeters here. Nearest half of 1 millimeter will be 0.5 millimeter. I don't know why it's freezing up. So this will be plus, and then this will be minus 0.5 millimeters. Alright, almost there. So work out the greatest number of spheres that could be made from the metal. Okay, so let's record. So the metal cube has size of length 4.5. Okay. The cube is melted down. So this particular cube is being melted down and the metal used to make small spheres. Each sphere has a radius of 3 millimeters. So you can see it's being reduced greatly. The first thing we should do is convert everything to the same unit. So let's make everything to centimeters. So we can start this off. So for a cube, at least in this case, we want to find the greatest number, right? So you want to find the upper bound for a cube. Okay, so the upper bound for a cube would be 4.5 centimeters plus 0.25 centimeters. This is going to give us a maximum upper bound of 0.75 centimeters. Good. And then this is per length. So because it's a cube, we can just cube root it. So therefore, the volume of a cube would be 4.75 cubed. Okay, and the answer here would be in cube centimeters. Okay, so that's fine. Now for the sphere, we need to work in centimeters too. So we can say for every 10 millimeters is 1 centimeter. So 3 would be 0.3. So for sphere, we're going to have 0.3 centimeters. And the main idea is that the method we're going to use to calculate the greatest number of spheres, we need to divide firstly the metal cube by the sphere itself. So the solution would be the volume of the cube over the volume of the sphere. This would easily give us the greatest number. Because remember, they melt down, so in other words, it reduces itself. So we know the volume of the cube would be 4.75 cubed. Now the volume of a sphere, well, we need to find a lower bound because you want to find the greatest range. So we need to subtract it against, in this case, if it's 0.5 millimeters, it should be in centimeters 0.05 centimeters, which will give us 0.25 centimeters. Alright, not bad so far, not bad so far. Okay, so just catching my breath here, guys, yeah? So we got a sphere, so this is the radius, yeah? So I should just make a quick note. So this is the radius, yeah? And the cube was just the length. So the volume of a sphere is going to be 4 over 3 pi r cubed. So pi r, which is 0.25 cube. And that's it. Now all we literally do is plug into this formula and then smash it on the calculator. So throw in the volume of the sphere below here. We should get 4 over 3 pi 0.25 cube. So this formula for sphere is actually in the front page. You'll find it in the front page of your exam booklet. And yeah, and that's it. So work out the greatest number of spheres that could be made. So now put this in your calculator exactly as you see it. So 4.75 cube over 4 over 3. So this question, it was a bit tricky, I admit, because the wording itself, you need to spot that you're dividing the volumes in order to find the greatest range. So you should get about, let me see, 1,637.465 so on spheres. And in the case of this, because you need to round efficiently, it's literally safer to round downwards because you've effectively made this many spheres. These ones are still in production, so you can consider the decimal value to be incomplete spheres. So let's just say we have 1637 spheres. Alright, I hope this is actually correct, but this is how I believe the method should be used. Alright, let's move on to the next question. Alright, we did really well. We did really well so far. Alright, number 21, guys. It looks like we're almost there. I think we're coming to the end now. So we have 9 counters in a bag. There is a number on each of the counters. So we've got 2 1s, 3 2s, and 4 3s, conveniently. Cal takes at random 3 counters from the bag. He adds together the numbers on the 3 counters to get his total. Work out the probability that the total he gets is a 6. So naturally, all we have to do is find every combination to get a 6 here, it seems. So what combinations do we actually have? So let's start from the lowest here. So if we pick a 1, then we need to pick a 2, and we can pick a 3. This will give us a 6. Another combination could be 1, 3, 2. Another combination, so I think that's it for 1. We can get 2, 2, 2. Yep, that works. We can also get 2, 3, 1, and obviously 2, 1, 3. Now, starting from 3, we can get 3, 1, 2, or 3, 2, 1. Alright, so now to work out the probability, all we literally do is find the probability each one. So we're just taking a p for each term. And now all we simply do is calculate. So the probability of getting a 1 firstly, so we've got 9 counters, to get a 1, it will be a probability of 2 over, how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll be 2 over 9. So I think I need more space. Do we have more space? Yes, we do. Okay, let me just move this across here. Give me a second. No. So select. Okay, give me a second. I'm just going to stop this video for a moment. Okay, here we are. So I've moved it across now, all below. Now to work out each probability is easy. So we look at the probability of getting a 1 firstly. So you take a 1. So every time you take a count out, it gets removed. So you're left with a decreasing number of counters. So probability of getting a 1 first would be 2 out of 9. Just write down. So let's have a go. So 2 out of 9 times probability of getting a 2. So you got 1 less counter. You have 1, 2, 3. So you got 3 out of 8 counters remaining. And to get 3, you got 4 counters out of 3 over 7 remaining. So it'll be decreasing every time. So that's what we need to know. Next one, for 1, 3, and 2, it'll be the same thing. So probability getting a 1 would be 2 over 9 times probability getting a 3 would be 4 counters of 3 over 8 remaining. And to get 2 would be 3 over 7. So one thing to know about this probability is that you're bound to get the same results. Like to get the same results for similar ones like 1, 2, 3, 1, 3, 2. So we can grouply just summarize, we can just multiply the number. So there's 2 lots of these, we just say 2 lots of these. However, probability 2, 2, 2 is unique. 2, 1, 3 matches with 2, 3, 1, and 3, 1, 2 matches with 3, 2, 1. So let's do it. So probability getting a 2, again recalling there's 3 2's in the bag. So the first time will be 3 over 9. And then you've taken a 2. The second time will be 2 over 8. And the last time will be 1 over 7. Because there's only one more 2 left at this stage. To get a probability of 2, 1, 3, it's going to be the same as the first 2 because they got 1, 2, 3, 1, 2, 3. So it'll be the same as the first result as above. So you can say same as this one. 2, 3, 1, same as previous. 3, 1, 2, same as previous. And 3, 2, 1, same as previous. So to summarize, we can say that the total probability of getting 6 is going to be this. It's going to be 6 lots of the first equation because they're all the same. So 6 times 2 ninths times 3 eighths times 4 sevenths plus, what was the unique one? The probability of 2, 2, 2. So 3, 2, 1, so times, so let's work this out. Times 3 times 2 times 1 will give us 6 over then 9 times 8 times 7, whatever that is. That's it. Now, yeah, literally just enter this in a calculator. So have a go at this. Have a go. I'm going to quickly evaluate this as fast as I can. So 2 times 3 times 4 over 9 times 8 times 7 plus 6 over 9 times 8 times 7. So I got 25 over 84 equals 25 over 84. And that is equivalent to, who do they want answering? Or they don't really say. That's equivalent to 29.8% to three significant figures. 8%. All right, sweet. So that's something, isn't it? So not too terrible. Again, it's all the same method. So just look at the combinations and you'll notice that there's a recurring answer in every time. Now, moving on. So the diagram shows a pentagon given by the following information. And all we have to simply do is work out its area. Okay. Looks straightforward because this looks like I don't want to say an isosceles-ish pentagon, so we can split it through the center because they all got the same same value. So let's have a go at that right now. So let's put a straight line here and split it down. So this will tell us instantly that we're going to have a height over here of varying length, and that this length now is going to be half of 13.2. So 13 over 2 here and 13 over 2. All right. What is the next step here? So we want to find areas. So what we have here is a quadrilateral, and yep, okay, looks pretty straightforward. Okay, so basically to solve this, we need to split this up into another quadrant. So let's have a look. So what I would do, I would draw a straight line from the top right to this corner. So you'll see that you're going to have exactly two triangles here. And if we repeat the same thing, we're going to have another two triangles. So we need to find the area of 4 triangles. Okay, so this works with pretty much any polygon. If they use this kind of method, it's best to split them up to as many triangles as you can. So yeah, now this looks quite easy, doesn't it? We can see that we have a right angle triangle here. I mean, the only issue is that we have a height h. So if we can work out the value of h, we can work out the area of this right angle triangle. As for this triangle here, if we can work out the length of, this hypotenuse for the right angle, then we can find out what the h is. However, we can actually work out the area directly for this triangle because what do we have here? We got a length here. We have an angle between two lengths, and this follows the rule, which is half AB sine C. This half AB sine C is the area of a triangle. Basically, it's saying that if you got two lengths A and B and an angle C between the two lengths, you can work out its area using this formula. So that's sweet. So that's done. However, we still need to work out this length, and to work out this length, we kind of need to use the cosine rule. So let's call this length x, yeah. And using the cosine rule, let's work with this triangle here. So 8, 12, x, and 105. Okay, and then once we do that, we can work out the h using Pythagoras theorem. And then find out the areas of both and then just double it to get the answer on the right. So let's call this triangle 1, yeah? So let me just draw it nicely because I like to draw the shape. So to draw the shape, ink to shape, we're going to have, just to make it clear, something like that, isn't it? So here we've got an angle 105, so we've got 8, 12, and x, and we can call this angle 105. So using the cosine rule, cosine rule applies the same like previously. We can let the angle, the concerning angle A, and let the opposite angle be known as small a. And using the formula, which is a squared equals b squared plus c squared minus 2bc cos a. So yeah, this formula you get in the front of the page as usual. And notice how we want we want the capital A, which is here, the only angle, which is that, and its opposite length, which is small a, which is that. So plug in everything in, what do we get? So a squared is x squared equals, and then b and c is irrelevant, so you can pick 12 or a. So 12 squared, which is 144, plus c squared, which is 64, minus 2 times b times c cos 105 or 103? God, I can't. My handwriting is awful. 105. Yeah, and literally just plug it into your calculator, and once you get a result, all you simply need to do is just cos inverse it. So 105, let me just check if it's in degree. So you should get an x squared value of, let me just do it in steps, of something like 257.693. Square root this answer, so we can do the square root of answer. You should get, that's it, you should get x value of 16.1 centimeter, 3 single figures. Now, using the right angle triangle part, so let's draw the right angle triangle. Okay, so the right angle triangle. Okay, oh that's amazing. We're gonna have lengths of 13 over 2, so what's that? 16.5 h and x. So let me 16.5, 6.5, 16.1 and h, and that's it. So using Pythagoras' theorem, which states that we have a squared plus length b squared equals the hypotenuse squared. So a squared, which is 6.5, times b squared, which is h squared, equals the hypotenuse squared. And just rearranging this, making h subject, I think we can do this. We subtract 6.5 squared to that, and then square root the whole thing. So you can get something like 16.1 squared minus 6.5 squared, and then square root your final answer. And that's it, guys. You should get 14.7 to the nearest 3 single figures. Oh, okay. Now, what's happening here? All right, so now we've got a length. So therefore, let's find the areas now, okay? So using the area of the first triangle, let's do the first triangle right here. So the area of this triangle here, what's it going to be? So half AB sine C. So literally just half times your two lengths, so 8 times 12, and then sine 105. And then the area of this triangle here would be literally half times base times height, which is half times 6.5 times h. So the area of this whole thing is just half times 6.5 times h, which is 14.7. And then when you evaluate both of these results, add them together and then double it. And then you should get your pentagon area. So let's evaluate them quickly. So evaluating this one should give us sine 105. Should give us, oh, okay, so this gives us an exact result. But as a decimal, well, let's write the exact result actually, yeah? No, let's write the decimal. So you should get, for the big triangle on the left, you should get 46.3644 plus, and then work out this other triangle. So you do half times base, which is 6.5 times the height, 14.7. So add it together with the previous solution. So it would give us 9. So adding together with the previous one, so the left hand side should give us 94.139. And then doubling this one, we should get an answer to how many single figures? The 3 single figures of 188. Damn. Okay. Hopefully that was a bit clear. That was clear. So find the area of this side of the triangle of the pentagon and find the area of the right angle triangle using this formula. Add them up and double it, you should get 188 rounded up. Cool. Not bad, guys. Not bad. That wasn't too bad. All right. And that's it. That's the end of the paper. Wow, we did it. All 22 questions. My God, it was getting challenging, and I have to admit, I was actually thinking about it a lot at the same time. That it definitely gets a bit challenging to do a whole paper and to record at the same time. But I mean, I just want to say thanks. If you guys managed to see every single question, I appreciate it. And you know what? Let me know in the comment section if you want me to make more, or if you've got any other particular problems. I also recommend that you guys watch my daily maths video series, because I have a lot of questions and I'm always uploading every day to help you guys boost your GCSEs. So check that out, just check out and let me know again if you've got any other questions, and I'm always going to be posting something. So until then, I'll see you guys down the road, and ciao.